Welcome to section 2.6. We're going to be talking about graphing rational functions. Rational, ratio, talking about fractions. So if we're looking at f of x equals 1 over x. Now, x, because it's division, cannot equal 0. Now, if we're approaching that from the left, so if we're dividing, 1 divided by negative 1 is negative 1. 1 divided by negative 1/2 is negative 2. Negative 0.1 is negative 10. Negative 0.01 is negative 100. Then negative 1,000. So as we're approaching 0 from the left-hand side, we're heading towards negative infinity. The closer we get to 0, the further down it goes towards negative infinity. As we're approaching from the right, when we divide, 1 divided by 1 is 1, divided by 1/2 is 2, divided by 0.1 it's 10, divided by 0.01 it's 100, 0.001 it's 1,000. And as we're going from the right-hand side, we're approaching positive infinity. So if we were to graph that, what's happening here, 1, 1, everything else is going to get like just smaller and smaller and smaller and smaller here. And then it's just going to keep getting bigger and bigger and bigger and bigger and bigger and bigger and bigger there. Same thing here. So what this graph is going to look like is it's going to have an asymptote. It's going to have a vertical asymptote at x equals 0 because x cannot equal 0. It's going to have a horizontal asymptote at y equals 0. We're never going to get to 0 for y. So our graph is going to look like this. This is what those asymptotes do. It's going to kind of just go straight up in the air. And here's our graph. Now, for this basic rational function, our domain, we can use any real number we want to as long as it's not 0. So it's going to go from negative infinity to 0 with a parentheses, and then from 0 to infinity. Our range, same thing, negative infinity to 0. We're never going to get to y equals 0. Our horizontal asymptote, HA for short, x equals 0. And our vertical asymptote, that's our vertical asymptote, VA for short, is x equals 0. And a horizontal asymptote, y equals 0. That's a basic rational function. And we call that graph, in this case, a hyperbola. Let's go to the next page and see some more. So there's some talk about the asymptotes and such. Remember, I'm using HA and VA for short, just because it's a lot of work to keep writing that. So we're going to sketch the following. So to start, we want to find out what can x not equal. Well, now for this, x cannot equal negative 1. Set x plus 1 equal to 0. X equals negative 1. That's what we can't have for an input. So we have, in this case, a vertical asymptote at negative 1. And you'll see if you graph this on the calculator, make sure you use grouping symbols around the numerator and denominator, that you have your horizontal asymptote at y equals 2. And your graph, your hyperbola, is going to look like this. I'm just using the graphing calculator to come up with these. Now, x squared plus 1. So let me label the asymptotes real quick. The vertical asymptote, x equals negative 1. The horizontal asymptote is at y equals 2. And we'll talk about how we can generalize those in a few moments. Now our denominator, set x squared plus 1 equals 0. X squared equals negative 1. Take the square root. X equals plus or minus I. That's not real. That's imaginary. So we don't have any restrictions on x. And when you graph it, you'll find out that there's a horizontal asymptote at y equals 0. And the graph looks like this. That's the shape of the graph. So our vertical asymptote, there is none. And our horizontal asymptote, y equals 0. Number 4. To find out what we can have for x, set x minus 1 equal to 0, so x equals 1. We have a vertical asymptote where x equals 1. Now our horizontal asymptote is at y equals 0. Like I said, you're using the graphing calculator to come up with these. And the graph is interesting looking. It looks like this. There's this graph. So the vertical asymptote is at x equals 1, and the horizontal asymptote is at y equals 0. Now on the next page, we can start making some generalizations. This next page is important about how to find those asymptotes. The vertical is the real zeros of the denominator. Just set the denominator equals 0 and solve. You'll find the vertical asymptotes. The horizontal asymptotes are a little bit different. It deals with the degree of the numerator and the denominator. When the degree of the numerator is less than the degree of the denominator, it's always going to be y equals 0. When they have the same degree, it's going to be the leading coefficient of the numerator over the leading coefficient of the denominator. Y equals that. And when the numerator has a greater degree than the denominator, there are no horizontal asymptotes. So make sure you keep referring back to that as we go through these next problems. So looking at problem number 5, we're going to find our asymptotes. So the vertical asymptote, 3x squared plus 1 equals 0. 3x squared equals negative 1. Divide both sides by 3. X squared equals negative 1/3. When you take the square root, it's not real. You're going to get plus or minus I something, something, something. So it's not real. There are none. For the horizontal asymptote, the degree of the numerator is 1. The degree of the denominator is 2. Now 1 is less than 2, so n is less than m. Looking back at the rules, when that's the case, it's going to be y equals 0. So our vertical asymptote, there is none. The horizontal asymptote is at y equals 0. You can use your calculator to sketch a quick graph of this. Now you'll notice the graph is going to look something like this. It's going to go, and then pop back down again. The horizontal asymptote only affects the end behavior. If you see in there, inside the graph, we did cross the asymptote. But once you get to the ends of the graph, it never crosses that asymptote again. So the asymptote only affects the end behavior. Sometimes you have a graph crossing a horizontal asymptote. Problem number 6. For the vertical asymptote, set x squared minus 1 equal to 0. X squared equals 1. Take the square root. We get x equals plus or minus 1. We have 2 of them. For our horizontal asymptote, the degree of the numerator is 2, and the degree of the denominator is 2 as well. So 2 equals 2. When n equals m, it's going to be y equals the leading coefficient of the numerator over the leading coefficient of the denominator. 2 over 1, so it's at y equals 2. So the vertical asymptotes are at x equals negative 1 and x equals positive 1. The horizontal asymptote is at y equals 2. So our graph looks like this. Up here it looks like that. Over here it looks like this. And on the bottom it looks like that. So that's what the graph looks like. The calculator's doing all the heavy lifting. We just want to figure out how to find those asymptotes. Now for number 7. We're going to start by factoring it first. We're going to factor the numerator. We get x and x. So we get x plus 2, x minus 1. The denominator we're going to get, when we factor that, x plus 2 and x minus 3. So what we can do is we can see that the x plus 2's cancel. But we can't forget about the x plus 2 completely. We have to keep in mind that x cannot equal negative 2. So our new function, f of x, is going to be x minus 1 over x minus 3, where x cannot equal negative 2. Because if we put a negative 2 in initially, it would cause division by 0, and that's no good. So our vertical asymptote, set x minus 3 equal to 0, you get x equals 3. And the horizontal asymptote, the degree of the numerator and the degree of the denominator are the same. So it's y equals 1 over 1, so y equals 1. Now when we graph this, and we type this in, our graph is going to look like this. There's that side, and on this side. But once we get to negative 2, you'll see you can't have a negative 2, so we call that a hole in the graph. There's a hole in the graph. We can't have x equaling negative 2. A little bit trickier, but that's where it is. We're going to go to the next page. We're going to sketch some graphs a little bit more effectively, a little bit more in detail. You can read through to find out what it's going to be. There's a lot of information there, and we'll see examples of when we're going to be doing this. So we're going to find our asymptotes first. So the vertical asymptote, x minus 2 equals 0, x equals 2. The horizontal asymptote, the degree of the numerator is 0, the denominator is 1. 0 is less than 1, so it's the line y equals 0. Let's find those intercepts while we're at it. For our x-intercept, set y equal to 0. So it's 3 over x minus 2. Put the 0 over 1 and you can cross multiply. X minus 2 times 0 is 0. 1 times 3 is 3. 3 can never equal 0. That's not true, so there is none. The x-intercepts are always going to be the real zeros of the numerator. If you forget that, you can always find it anyway. For the y-intercept, y equals 3 over 0 minus 2. So y equals 3 over negative 2. Y equals negative 3 halves. So our vertical asymptote is going to be at x equals 2. Our horizontal asymptote is at y equals 0. Our x-intercept, there is none. And our y-intercept is at 0 and negative 3 halves. We'll find the domain and range in a moment after we graph it. So to graph it, make sure you put the parentheses around your denominator. I'm going to pick some values, negative 2, negative 1, 0, 1, 2, 3, 4. So I'm picking some values around my asymptotes. My vertical is at x equals 2. And my horizontal is at y equals 0. So that's why I picked the values today. I'm actually going to throw another one, a 5 here. The calculator's going to do all the work for us. You type it in, negative 0.75, negative 1, negative 1.5, 1, negative 3. Now we can't have the 2 because that's where our asymptote is. So when x is 3, 3, and then we're at 1.5 and 1. Excuse me, on the wrong side. Negative 2, we're at negative 0.75, negative 1, negative 1.5, negative 3. So the left-hand side looks like this. And on the right-hand side, we're at 3, 3, 1.5, and 1. It's going to look like this as we approach that asymptote. So there's our graph. So our domain, we're going from negative infinity to 2, and then from 2 to infinity. It's all real numbers except 2. For our range, we just can't have a 0, so we're going from negative infinity to 0, and the union of 0 to infinity. And there's our domain and range for that graph. All right, let's go and do one more, please. Number 9. So for our vertical asymptote, x equals 0. Horizontal asymptote, the degrees are the same. They're both degree 1. So y equals 2 over 1, y equals 2. For our x-intercept, it's the real zeros of the numerator. 2x minus 1 equals 0, so you get x equals 1/2. And for our y-intercept, y equals 2 times 0 minus 1 over 0. Can't divide by 0, so there is no y-intercept here. So our vertical asymptote, x equals 0. Horizontal asymptote, y equals 2. X-intercept is at 1/2, 0. Y-intercept, there is none. There's our asymptote. So when I make my table, pick some values around 0. So let's do like a negative 3, negative 2, negative 1. Skip 0 because that's where our asymptote is. 1, 2, 3. Calculator's doing all the work for us. So we get a 2.3, a 2.5, a 3, a 1, a 1.5, and a 1.7. So the left-hand side is going to look like that as it approaches the asymptote. And the right-hand side, we're at 1, 1, 1.5, 1.7. The right-hand side looks like this. So there's our graph. So our domain, for x's, we can't have 0, so negative infinity to 0, and then the union of 0 to infinity. And for our range, we can have 2. So it's going to be negative infinity to 2, and the union of 2 to infinity. Okay, we'll pick up with this in the next video. I will see you then. Thank you.